Well, thank you everybody for coming and joining us this evening to hear from Andrew Fraser, who I think is not going to disappoint you. He has been nearly a lifelong friend, and our association blossomed really under the shadow of the moon. As a 13-year-old, passionately enthusiastic new member of the fledgling Port City Amateur Astronomers Club in Muskegon, he was all in when he heard about a joint expedition to observe the total eclipse of the sun that was to sweep across southern Canada on July 20th, 1963. I was a grad student at the U of M at the time and met young Andy while back home in Muskegon doing a presentation about Mars for the PCAA earlier that year. And I'll bet Andrew, with his photographic memory, would remember that. I had some friends from GRAAA in Ann Arbor at the time and many at the PCAA in Muskegon. So that's how the joint expedition developed. And I just happen to have it. Jack, I think, has a picture to show you. See the young, good-looking kid there on the left. I don't have any idea who the geeky guy on the right is holding the other side
Yeah.
of the flag. And that's a rather motley group of people, including John Wesley, who was a pillar in the Grand Rapids astronomy group years ago, and a young Bob Moeller right
Mueller.
in the middle there. And this was on a hilltop overlooking a river up in Quebec, Canada. And that was the first opportunity I had to get to know Mr. Andrew Fraser. So if you want to, Jack, you can just go to the second slide because I'll be coming up with on that one fairly soon too. As an ambitious teenager, Andy initiated correspondence with Werner von Braun that resulted in an invitation to meet the famed rocket scientist during a trip to tour the Huntsville, Alabama Space Center, where the Saturn V moon rocket was being developed. Andy then he went on to graduate as valedictorian from Orchard View High School in Muskegon. Being a fellow Muskegon native, and first time shadow chaser with Andy. Our friendship was strengthened when good fortune brought me to the Grand Rapids Public Museum as planetarium curator and an active participant in the activities of the GRAAA, just as Andy was finishing high school and starting undergraduate studies at Grand Valley in the late 60s. Well, all of us in GRAAA realized that this was a man with exceptional potential, and it did not take long for me and other GRAAA leaders to draw him in to teach Saturday astronomy classes at the planetarium. We have some pictures of that too that I think you've already seen, and to assist some with ongoing construction at Bean Observatory around his busy college life. So now you've had a chance to look at this picture, and Andy's right there in the foreground on the right. And I suspect that you might have some trouble recognizing some of the other members. Some of them are deceased. I'm right behind Andy, I guess, and Bob Mueller is in the picture is to the left of me. And then, of course, there's Percy Hawkins. And who can ever forget Percy Hawkins? He was just
Yeah.
a unique individual, and Andrew might even have a thing or two to say about him if I ever shut up. So,
Another good Scotsman. Yeah.
yeah, he was just an amazing guy. Well, after that, he went on to have to determine what he was going to do with the rest of his life, whether he wanted to make a lot of money in business or wanted to be a professional astronomer. And at least temporarily, he decided he was going to go on to business. And he then went to the University of Michigan, where he obtained the first of three master's degrees. In first one in 1973 in business. Then he took a position in market management and development with the innovative consumer products giant 3M. I got through that part. Moving to Minneapolis, St. Paul area and remaining with the company until retirement in 2002. 2002, that is correct, right?
Yep.
That's when you retired. During his professional career, Andy acquired a second master's, this one from the University of Minnesota in business marketing in 1978. Through all this, Andy's innate passion for astronomy never faded, even while marrying Mary and raising three sons. In fact, shortly after leaving U of M and moving to the Twin Cities, he was a co-founder of what is now the Minnesota Astronomical Society. He was the group's first newsletter editor and has served the society as president, vice president, and board member. He remains active in the group that now numbers well over 1,000 members, or is it even more than that?
Approaching 1,000.
Okay, approaching 1,000 members. Incidentally, GRAAA is over 300 now. That's pretty
Very good.
remarkable. Over the years, picking up from his long ago PCAAA and Wien days, he was involved in the development of both personal and society-built observatories. You'd never get a word edgewise if we talked about all the projects you were involved in. Oh, yes. After retirement in 2002 and with grandchildren on the way, Andy confirmed his lifelong commitment to astronomy by embarking on his in-depth study of the life and distinguished career of astronomer Heber Curtis by completing work in 2017 on a third master's degree. And this one was in astronomy, correct?
Correct.
Doing most of the work online with Swinburne University in Australia. I hopefully got that right.
Yep.
Good. I'm near the end, Andrew. Throughout all this, we kept in regular touch, and I had a great visit with Mary and Andy back in 2003 in Minnesota. And then in 2018, Andy, myself, and two other friends from the Minnesota Astronomical Society, you can bring up the last slide now, Jack. We ventured to the Atacama Peninsula in northern Chile, where we together had a chance to stand under the Southern Cross as well as to explore telescopically the Magellanic Clouds and other deep sky delights. So there we are with Andy on the left, Mark Boyd and myself, and
Mark
Mark
Peterson.
Peterson. Yep. Andy has traveled to see a number of solar eclipses after he caught the shadow bug chasing the eclipse of 63. He was a participant in the joint GRAAA GVSC at the time. That was Red Valley State College expedition to the East Coast in 1970 while a college student. That's almost a story in itself. And was also at the 2017 and 2024 U.S. eclipses. He and Mary now travel worldwide, so I suspect he has plans to observe the big ones coming up in the Mediterranean in the next 2 years. He notes that during his extensive travels, he never fails to include places and facilities of astronomical significance. One final note. Yes, take a deep breath. We're there. I think Andy and I may have made the last significant observations ever with the historic Ritchie telescope at Yerkes Observatory before we messed up its wiring system. You remember that, don't you?
Oh, yeah.
We also made our first ever trips together to Lick, Mount Wilson, and Palomar observatories during an out west trip in 1967. And that would be another almost story in itself. So you can see why it's a particular pleasure for me to introduce a longtime and very, very dear friend with whom I have a considerable history, and you did not hear it all. Andrew?
Good evening. I'd like to preface my presentation with the point that several individuals from West Michigan have distinguished themselves in astronomical circles, both professional and amateur. And beginning perhaps with the most contemporary, Jacob Borgeli, noted for his particle physics research, U of M, Cambridge, Princeton, Copenhagen, and Penn State. Jim Ashley, University of Arizona, a planetary geologist, uh, major participant in the Spirit and Opportunity missions at JPL. Tom Palakis, another Muskegon native, an aerospace engineer, widely recognized in amateur circles around the country, and a Lowell Observatory research assistant. Tom Strickwerda, and he did his PhD at University of Virginia, which I'll have more to talk about as I'm talking about Heber Curtis. Um, Active at Johns Hopkins APL, the Messenger probe, and the New Horizons guidance. Jerry Persha, founder of Optech in Lowell, Minnesota. David DeBryan, another Muskegon native, longtime resident of GR, educator to countless, mentor to many, founder of the Great Lakes Planetarium Association, philanthropist in support of planetarium education, emeritus director of the Chaffee Planetarium, and stalwart for the GR AAA. Ralph Baldwin, U of M PhD in 37. His book, The Face of the Moon in 1949, outlined the case for lunar craters caused by impact rather than volcanism. And finally, Heber Curtis, about whom we'll talk quite a bit tonight. As we will see, his interests and capabilities went far beyond the technical expertise in fields of astronomy. The middle name Daust is pronounced to rhyme with soused, though seldom, if ever, was he. He, in close friend circles and academics, was referred to as HDC. The beginning of his career was a time when astronomy was changing from where celestial objects are to what they are via astrophysical tools, primarily photography and spectroscopy. Lick Observatory was at the vanguard of research. It was the first mountaintop observatory, and instrumentation was evolving from long focus refractors to large aperture reflectors. What prompted my interest in this was kindled by a 1965 visit by Harlow Shapley to Grand Rapids. He was the former director of Harvard Observatory and recognized as the Copernicus of Milky Way astronomy, taking the Earth and Sun, the solar system, out of the place of prominence that it had resided previously. And he was the advocate for the big galaxy hypothesis. Some years later, as I was pursuing my master's in astronomy coursework, I came across information about the University of Michigan Detroit Observatory, and in the process learned that Heber Curtis was from West Michigan, from, in fact, Muskegon. He was the champion of the island universe theory, which was the subject of the debate in 1920 with Harlow Shapley. The project that I undertook for my capstone in pursuing that master's was to delve more deeply into Heber Curtis's work, and it was titled Beyond the Great Debate. So I'm going to tonight focus mostly on things other than the Great Debate, although there will be some mention made along the way. The Great Debate in 1920 was conducted at the American Academy of Sciences, and Harlow Shapley uh, was the one opponent. His contention was the Milky Way was the entirety of the universe, spanning about 300,000 light years. Curtis, on the other hand, was one of those who supported the contention that spiral galaxies uh, were multiple in a vastly larger universe. The debate is largely considered to be a tie. There were multiple points of contention, and we won't go into the details here, but they're listed 14 of them that Virginia Trimble has noted in her writings. Uh, both contestants were right and wrong on a number of the points. The outcome was inconclusive. Uh, it wasn't until 5 years later that the argument was finally settled when Hubble found Cepheid variables in Andromeda. As a result, Curtis's arguments were inferential, and we'll talk more about that shortly. Curtis's contributions spanned a number of subjects in astronomy, from stellar spectroscopy and radial velocity measurements to observatory administration and instrument design. And we'll see along the way how each of them came about. But to understand Curtis really fully, I think we really need to take a look at his upbringing. Um, his father was Orson Blair Curtis. Um, he was a 10th generation American. Uh, he was born in Wayne, Michigan in 1841. In 1862, after having enrolled at the University of Michigan, he withdrew and joined the Company D Volunteers of the 24th Michigan. And he is famous for his chronicles of the war for that group of soldiers. Um, he suffered an injury at the Battle of Fredericksburg that resulted in the amputation of an arm. And remarkably, uh, he was mistakenly reported killed, when in fact it was a cousin of his who was killed. He returned to the University of Michigan, and as comments were being made from the pulpit about his exploits, um, he was greeted with thunderous foot stomping by his classmates as he entered the chapel. He went on after graduation to become the first superintendent of schools in Muskegon and the editor of the Muskegon Chronicle. Heber's mother was born in Maidstone, England. She was the daughter of a Methodist minister, and the family emigrated and settled in early Romulus, Michigan. She attended Albion College, and she was well versed in literature and music. And we'll see later that that shows up in Curtis's work as well. Curtis was born June 27th of 1872 in Muskegon, Michigan. He was the oldest of three children. The family moved back to the Detroit area when he was about 7 years old, and he attended Detroit High School. He was regarded as good at math, languages, and he had a strong mechanical aptitude, building his own lathe when he couldn't really afford one, still in high school, and very active in sports, despite his rather diminutive size. In fact, following high school, he attempted to enroll in the military and was rejected for physical requirements. When it came time to decide on a career, uh, he started in one direction and then accomplished what he referred to as the switch. Well, I'll ask you to indulge me with some verbiage on slides here. There's no pictures to show, but it's an interesting story how he got from where he started to a career in astronomy. Uh, he and his father disagreed on what direction he should take in his career. His father wanted him to pursue the ministry. He wanted to pursue engineering. The compromise they struck was that he would pursue classical languages. In 1892, he completed his bachelor's degree and his master's a year following in classical languages. And for half a year following, he became the Latin instructor at Detroit High School. The following year, 1894, he took a position as the instructor of Greek and Latin at Napa College in California. And this is where family lore enters the picture. I have spoken with descendants of his, and they believe this is how it happened. While he was a Greek and Latin teacher that first year, he was invited to a faculty gathering at the observatory at that school. And there was some mechanical problem with the drive for the telescope. That evening, he fixed the drive and enabled the instrument to work. And that earned him uh, subsequent invitations to return to the observatory. This is a picture of the observatory and the 8-inch Clark refractor that Napa College had. The second step in the switch was a fortuitous relocation. In 1896, Napa College and the University of the Pacific merged, and the two campuses were consolidated at San Jose, literally within eyeshot of Mount Hamilton, where Lick Observatory was located. The University of the Pacific had an observatory called the Jacques Goodall Observatory, and they had a 6-inch Clark refractor plus accessories. The aperture was smaller, but it was better equipped than the one at Napa College. Interestingly, both of these instruments uh, can be seen today. The uh, the 8-inch is at an observatory in San Jose on display, and the 6-inch is owned by a private instrument collector in New Mexico. This is the observatory, the Jacques Goodall Observatory at University of the Pacific, and that is Curtis on the second story. It's the first photograph apparently of him in an astronomical setting. The third step in the switch was another interesting occurrence. In 1896, the University of the Pacific decided to confer a PhD on Edward Holden, who was the first director of Lick Observatory. Because Curtis was the instructor in languages, he was assigned to prepare the letters and diploma to Holden. That gave him an opportunity to inquire regarding potential astronomical work for the 6-inch refractor at this school. And as a result, a mentoring relationship started. The next step was a year or so later. He actually became the mathematics and astronomy instructor. And as other biographers have noted, he was one jump ahead of his students, not having had college level formal training in that area. In 1897, by 1987, he had a defined observing program working with Holden, and he became a special student on the Fouth Transit at Lick during the summertime. In 1898, he applied to the Lick Berkeley PhD program, but he was blocked by A.O. Leuschner, who was head of that school's astronomy program. Leuschner was another uh, Michigander. He grew up in Michigan, attended the University of Michigan, then went to Germany, studied in Berlin, and then returned to California to take professional positions. Uh, Holden, who had been the mentor for Curtis, was replaced by James Keeler. And so he didn't have the support uh, to pursue what he wanted to in terms of a PhD, and he returned to his teaching position at the University of the Pacific. But uh, some other things happened, and um, in August of 1900, Keeler died. He had only been director for a couple of years, and W. Campbell became the Lick director. Uh, this was a very fortuitous connection for Curtis because he was another U of M alumnus. He had also had the experience of being a special student at Lick, and he himself had accomplished the switch from a different career to one in astronomy. He was a civil engineer by training. On top of that, his wife was from Grand Rapids. So, with that change in personnel, geographic, academic, personal, and scientific relationships all kind of fell into place for Curtis. Oop. Um, Early in 1900, Curtis had again applied for a Lick Fellowship. This was still when Keeler was director, and Keeler was discouraging him to do this. Uh, Keeler was looking for someone with astrophysical training background, specifically in spectroscopy. And he also felt that Curtis's background in mathematics was weak. So Curtis sought alternatives, and he ended up uh, getting a position to go study at the University of Virginia, same place as uh, I had mentioned uh, Jacob Bourget obtaining his PhD. His studies there were under Ormond Stone, and he was working on on comet orbits. Uh, Again, not astrophysics work, largely positional astronomy, but it was a route for him to get his PhD. But just before he was to leave Lick to go commence those studies, Lick organized an expedition to go to the total solar eclipse in Thomaston, Georgia. And Curtis was able to go along. And at that expedition, he commended himself very well working on the instruments which were having problems. And it was noted by Campbell. Uh, the result was before he left to go to Virginia, Campbell extended the invitation to him that when he was done with the PhD, for him to come back to Lick. He completed his PhD in 2002, again with the orbit of Comet 1898 F1, and he returned to Lick. Uh, the irony here is that he picked up in his first assignments work started by Keeler that was really astrophysical in nature, using stellar radial velocities to determine the space velocity of the sun. Um, and uh, Radial velocities ultimately became one of his preferred supporting forms of data to support the island universe theory. Along the way, dozens of spectroscopic binaries were discovered, and he and Campbell produced a paper discussing the reflex motion of the sun, which is really a harbinger of one of the ways that we can today uh, determine the existence of exoplanets. And in the process of conducting this work, Lick became a world leader. In 1903 through 1905, Lick established the D.O. Mills expedition to establish an observing facility in Santiago, Chile. This was largely to continue the radial velocity program, and the first observers there were W.H. Wright and H.K. Palmer. Uh, After 2 years of getting the instrument up and established, Curtis was assigned to head up the facility. And in the course of conducting that work, another 48 spectroscopic binaries were discovered. As a testament to his language prowess, though, that you'll remember that's where he started, he represented the U of M at the Fourth Pan Am Congress and presented three papers in Spanish. This is what the D.O. Mills Observatory looked like in about 1905, and the 37-inch reflector. And interestingly enough, having visited, this is what it looks like today. Aside from the growth of vegetation around the observatory, uh, it looks pretty much, in my view, like what it looked like in Curtis's time. Today, it's known as the Manuel Foster Observatory, named after a benefactor who preserved the facility, and the instrument is still used for public outreach. In 1909, he returned to Lick, uh, replacing Charles Perrine, who was a staff astronomer who became the director of the observatory at Cordoba, Argentina. He continued photographic studies of nebula, and he began with uh, work on planetary nebula. At the time, fewer than 100 were known. The distribution suggested that they were galactic in nature, but their origin, actual structure, and dynamics were largely unknown. Morphology is the classification of objects by shape, and Curtis is well recognized as the first to establish a morphology scheme for planetary nebulae. He broke them into groups A through G, including things like helical, annular, disk, and stellar. And this enabled several nebulae to be sorted into whether they were actually planetary or diffuse. And M76 is one of the best examples of that. Um, this is a photocopy of the reprint of his magnum opus in this field, and M76 is this one right here. A legacy of his work in planetary nebula is left in the name of the helical nebula, NGC 7293. Uh, this object is the archetype of the helical type planetary morphology. By taking photographs at various brightnesses, he was also able to discern structure within a number of planetary nebulae. And he was the first to reveal the true nature of M57, the ring nebula, to be a toroid figure on the plane of the sky. His work also included many spiral nebulae, of which there's a substantial lexicon legacy. He was the first to note the bar or phi type structure in some spiral galaxies. He was also the first to term lanes describing occulting matter between the arms of spiral galaxies. And he's credited with the discovery of the, quote, curious straight ray apparently connected with the nucleus by a thin line of matter in M87, today recognized as the relativistic jet extending from the active galactic nuclei of this massive elliptical galaxy. It's probably appropriate as we look at some of his galaxy work to recognize how his communication style was impacted by his classical training. Uh, at this time, you got to realize, and this would be like in the late 1919s, late teens of 1900, when conjecturing about the nature of spiral nebulae as solar systems in formation. In the classroom, he quoted from Tennyson, the Princess, "This world was once a fluid haze of light, till toward the center set the starry tides, and eddied into suns that whirling cast the planets." Not the way most astronomers, I think, would verbalize the concept of a planetary system in formation. So again, I'm not going to go into great detail about the the great debate, other than to say there are two two considerations that should be mentioned. Without diminishing Hubble's work, several people feel that um, Hubble did not single-handedly discover the extragalactic scale. And Curtis is important in this context for 2 points. First, uh, recognition that the novae in spirals were could function as standard candles, different from galactic novae. Um, and second, the line of inferential argument that he used in the face of von Manin's internal motion data, which I'm going to talk about here very shortly. On the first point, two seventh magnitude novae had been seen in the late 1800s in Andromeda and in NGC 5353. They were comparable to other galactic novae, so it was presumed that the objects that in which they resided must be relatively nearby. This was taken as evidence supporting spirals as galactic features. Curtis, however, found 14th magnitude novae in NGC 4527 and two others in NGC 4321. Curtis was very cautious in releasing his findings, and that same year, Ritchie found novae in NGC 6946, and his publication predated Curtis. Curtis had actually, from his data, looking at historical photos of those two objects that he found the 14th magnitude novae in, uh, he was able to, since they were invisible in earlier photos, he was able to estimate, based on the brightness that he observed, that the spirals were somewhere in the neighborhood of 20 million light years distant, and that their size was in the order of 60,000 light years. Not grossly inaccurate from what we might understand today. So he came to the conclusion that really the supernovae were key to the galactic scale. It wouldn't be until sometime later, however, that it was really understood by Zwicky and Bada that supernovae were a totally different class of nova. The uh, the second point was the line of inferential arguments that he used to support the contention that the spirals were extragalactic. These are the points that he relied on, and they are all inferential. None were definitively supported by observation. That would remain for Hubble's work to define. Um, he was confronted in the great debate with a set of data by an opponent, um, von Manen, uh, who was an observer at Wilson Observatory. Von Manen claimed that he had measured internal rotation within spiral galaxies. And he was supported by a number of others. He had considerable credibility. Um, and yet, Curtis uh, undertook his own um measurements uh, to try to determine whether or not he could measure uh, rotational motions. The evidence, in his view, is uncertain, but his weak math training and his own personal self-doubts about the data were a deterrent to direct confrontation. Um, it's interesting to note that in this period, as he was trying to support his arguments with the inferential uh, arguments, he he was plagued by a history of problems that kind of went back to his weaknesses in math. Prior to the assignment in Chile, he had submitted an article for publication that was found to have serious computational errors, and it was an embarrassment for Campbell, his boss. In addition, Curtis never accepted Einsteinian general relativity. So this kind of raises the question, what other biases might he have had? Curtis analyzed the results from the Lick solar eclipse expedition at Goldendale in 1918 for gravitational deflection, which, if he had found a positive result, would have proven or offered support for proof of Einstein's general theory of relativity. His results were negative, and Campbell declined to have them published. In fact, correspondence reveals a suspect history for Curtis's work regarding computational accuracy. Here are the quotes from Campbell. Uh, as you read them, uh, he was Campbell was frankly critical of his computational capabilities, and this may have played a role in Curtis's reluctance to challenge von Maunen's claims of measuring rotation in galaxies. Whether self-doubts regarding computational capabilities or bias against the spirals as galactic features, or perhaps his gentlemanly nature to engage in unseemly confrontation with Van Manen, all of these factors may have played a role in his approach to the argument and hence relying only on the inferential arguments that he had. The Great Debate largely marked the end of HDC's career as an observational astronomy investigator, but he would have other kinds of major contributions to make. Shortly after the debate, he took the position as director of Allegheny Observatory in Pittsburgh, Pennsylvania, chafing at the loss of mountaintop skies at Lick. Nearly a decade he would spend here providing opportunities largely in instrument development. Throughout his career, he had been a developer and builder of instruments, dating even from his days at Napa and UOP, correcting those instruments. At Lick, he was an evaluator and corrector of instruments. The 1900 eclipse expedition got him his first job at Lick. In Chile, he employed refrigeration to stabilize long period photographs, which was a total innovation. And he made several mechanical and ergonomic improvements to the Lick Crosley reflector. While he was at Allegheny, he undertook a number of projects for that observatory as well as others, such as Sproul Observatory. And then along came a very attractive opportunity for him to return to his alma mater at Michigan. Not just lately at Allegheny, but through his whole career, he had been engaged with instrument development. And here, the University of Michigan had two large projects initiated by his soon-to-be predecessor, uh, Curtis, spelled with two S's, who was the director at Michigan at the time. One was to be a large new telescope, and the other was the nascent McMath-Hulbert Solar Observatory. The new large telescope at Michigan was originally to be a 60-inch diameter, but developing capabilities to make ever larger glass blanks for the ultimately for the 200-inch at Palomar led to the casting of an 86-inch diameter blank. Unfortunately, it turned out not to be of suitable quality, uh, but astute as Curtis was, he managed to negotiate the recasting to be 98 inches. Uh, Unfortunately, despite the fact that the blank was cast and it turned out to be of suitable quality, the project was never to be completed. The Depression intervened. Uh, Even as director, he took a 20% pay cut, and all of the large projects were scrapped. This is a drawing of the instrument and the observatory as it was conceived, and it was penned by Curtis himself. The blank sat in a crate next to the observatory director's home uh, for decades, from the 30s to the 60s. And this is the crate with Curtis. And another photograph here is just for David DeBryan. The young lady that is standing next to the crate with the mirror is Dr. Hazel Losh, who Dave will remember from his days at Michigan. For those of you who may not know the history of Dr. Losh, she was an institution at Michigan herself and renowned for her grading scheme that went like this: A is for athlete, B is for boy, C is for co-ed. It was a different time. The blank sat in the crate until 1967 when it was sold to the United Kingdom, and it became the primary mirror for the Isaac Newton telescope at Hurst-Monceau. It didn't last long at Hurst-Monceau, given the the climate at that observatory. It was eventually moved to the Canary Islands. The mirror was since replaced, but the original blank is still on display. The second project was the McMath-Hulbert Observatory. It was initiated by Francis McMath and his son, Robert McMath, uh, at Lake Angeles near Pontiac, Michigan. Their partner in the project was uh, Henry Hulbert, and Hulbert, it turns out, was a classmate of Curtis's at Detroit High School. Hulbert was a judge, and they started an informal relationship with the University of Michigan while Curtis, spelled with two S's, was still director. But in 31, about a year after HDC became chairman, the the relationship was formalized. McMath-Hulbert Observatory made a number of significant contributions to solar astronomy. They produced the first motion pictures of transient solar features. They disproved the light pressure theory of prominences. Um, they developed techniques for 3D feature observation, the observation of material motions in the line of sight, and the measurement of velocities. And the observatory still exists today, although it's under private ownership. The same time at Michigan, uh, Curtis taught a course in cosmogony. Cosmogony is different from cosmology. Cosmology deals with the overall structure of the universe. Cosmogony focuses on the creation of the solar system, and it actually also includes considerations of philosophy and religion. And this kind of leads us into his body of work uh, in philosophy uh, and religion. He was a teacher and mentor to many at Michigan who made substantial contributions to astronomy. Um, I had not realized until I started looking into all this that one of the individuals David DeBryan and I had the pleasure of meeting at Yerkes was William A. Hiltner, who was at the time we met him, the director at Yerkes. The others are also well-known um, well-known contributors to the field. He was a Curtis was a lifelong devout Methodist. He was definitely a theist. He made a couple of statements that are well-regarded quotes. One, an undevout astronomer is mad, and the more I know of astronomy, the more I believe in God. He, on the other hand, said he could never prove the existence of God nor conceive the infinite. He was agnostic regarding the great unanswered questions in life. He had a humanist perspective. He felt that discovery in science of his generation dealt with classes versus units, and that to really examine classes of objects necessitated collaboration. Uh, his he is regarded by Aiken in one of the biographies as having a love of his fellow man and an eagerness to always be of service. It's recounted that when he lived at Lick, he was one of very few astronomers who had an automobile, and he was continually running people who needed assistance down the hill, so to speak, uh, when time was needed. He also regarded science of his generation to be something different than the previous generations. Previous generations, he felt, were strict. Their view of science was strict, infallible, and unyielding. He felt that science of his generation was characterized by change, growth, and progress. And one quote of his in that regard was regarding theory as policy rather than as creed. And it's even true, I suppose, of the island universe theory that he promoted. Uh, as time passed and we understood the interaction of galaxies in groups and how they interact and evolve. They are much less like islands than interactive bodies. Science, he felt, was things known with an attempt to arrange them in some orderly fashion. In that regard, he enumerated a space factor, which he pointed to with the variation in the size of galaxies, all the way from Andromeda to the very minute. A stuff factor, which is the fact that it appears that the material that makes up the physical universe is the same in our neighborhood as it is even in the most distant parts of the universe. And finally, a time factor that shows that the eternal conservation of matter and energy. And from this, he extrapolated that therefore the spirit, soul, or mind also must possess continuity. So, in conclusion, uh, beginning with parental models that gave him unique communication capabilities and taught him perseverance to a religious devotion and geographic and timely coincidence along the way, colleagues who provided precedent for him, professional acquaintances that were linked by origin and institution, all resulted in an incredible career that resulted in significant contributions in multiple fields of astronomy. And now I have to give you one more little bit of backstory. When I first started investigating this subject, and I learned that he was born in Muskegon, Michigan in 1872. At that point in time, Muskegon was the lumber queen of the world, but it didn't have a hospital. So he was very likely born in his home, his parents' home. At the time, his father was the first superintendent of public schools for Muskegon. And as part of that position, he was provided a home across the street from the high school. On the right side here, where the letter A is, this is the high school. And the high school burned down in 1890 and was replaced by the structure that is there now. At the same time, the block bounded by 3rd, Webster, and Clay and 4th was torn down and made into a park. But the house was right here at the corner of 3rd and Webster. This is a photograph of that park today. And in the early 1950s, when I was too young to attend church, my father would take me on Sunday mornings to Hackley Park, and we'd sit on a park bench right about here and feed the pigeons on the location of Heber Doust Curtis's birth. So that's all I have. If there's any questions, I'd be happy to try to answer.
Andrew, thank you very much. I hear applause coming from the audience in my imagination. And we will be, of course, maintaining this wonderful program for posterity. Uh, Quite an insight indeed. And it brought back a few memories for me, particularly of Dr. Lash.
Change your watch. I
Yes.
figured as much.
And a few other of the characters that were at the University of Michigan that followed. Did Curtis actually die in Michigan?
Yes, he did. He died at the director's house. He suffered from what was it? It was a chronic illness that he had, which finally took him. I can't recall right off the top of my head.
So
I
it really did come full circle, and he had a long, long relationship with the University of Michigan
Yeah.
and adjunct
And
facility.
despite his location, in California, it was a lot of Michigan contacts that he had that helped him along the way. It was just remarkable.
I bet
uh,
a couple people in the audience
Andrew.
can remember going to the McMath-Halbert Observatory. We had a
Uh-huh.
couple of expeditions over there. It is near Saginaw, I believe, so it's not that far away.
Yeah.
And I
Andrew, do you
actually
have
did a
time
little work
to
up there.
answer some Q&A questions? Do you
Sure
have any
Sure.
of those? And if people have any, they can type them in. So there's one from Craig Reynolds, and Craig asked, if Curtis were to look through the James Webb Space Telescope, which aspect of modern cosmology do you think would surprise him the most, given the arguments he made in the 1910s?
Mhm. Uh, I think the scale of things that are visible now, um, he was able to grasp larger scales, I think, than a lot of his contemporaries, and that may have actually been um, enhanced by his kind of profound belief in the infinite and God and the nature of the universe. But I think even he would have been most impressed with the scale that we understand the universe to be today.
Mhm. Cool. And this one isn't a question, but Aaron Anderson says, this was great. So much information. Look forward to doing some follow-up research after this. So thank you, Aaron. Yeah.
Enjoy. There's a ton of literature out there, but no consolidated biography that incorporates all of it. And Rudy Lindner at University of Michigan has uh, has been very helpful to me and explored a lot of the correspondence and everything of Curtis, which is resident at the Bentley Library in Ann Arbor, along with Dr. Pat Seitzer, uh, who's now retired. He has as well. He was the one who actually sent me the diagram of the Michigan telescope that had been penned by Curtis. There's also a lot of documentation at the Shane Library at the University of California, um, which I was fortunate enough to find a collaborator out there to help me dig into. So there's a lot of stuff out there.
Nice. Oh, we got another question. Craig asks, was there a specific observation in particular that convinced Curtis the Milky Way was not the entire universe?
Um, I think it was the fact that the radial velocities of galaxies are so much greater than any object in the galaxy. That was kind of the clincher
Hmm.
for him. That was his favored piece of data.
Hmm. Interesting. Cool. That's all I have right now.
All right.
Cool. Thank you for your questions.
On behalf of the organization and everybody, we want to thank Andrew for his presentation. Uh, our ranking officer this evening, Tom Good, has been unusually quiet. Would you like to say a word or two, Tom, about what's coming up?
Well, the last item on our 2025 calendar is the holiday party, which is on December 11th at Boulder Creek Golf Club. We always have some entertainment, and by special request of President Emeritus Dave DeBrine, we'll have a special presentation. I'll just say that it will involve some drama, and I'll let the rest be a surprise when people show up. You can now reserve your pay for your tickets, you pay for your dinner, and reserve your place by going to the website. And I think the email that reminded people of tonight's presentation also has a link for that as well.
Cool. Great.
Jack, can I put you on the spot because you have been making the arrangements for the first program that we're going to have in January, which will be on the 20th. Can you, I think, because you've already heard the presentation, so perhaps you could say a bit more about it.
Yeah, I don't know how much I can say just off the top of my head, but yeah, we'll be hosting a meeting at the museum in the planetarium. Uh, that'll be a Tuesday, January 20th, and we'll have Dr. Shannon Schmall from MSU do her astronomy update. So it'll be kind of an overview of some of the headlines you might have seen over the past year of 2025. And so, if you have some questions or some headline that jumped out at you, that might be a really fun one.
And then the program committee is working on the full agenda of programs for next year. We have some really exciting possibilities, including a couple of major speakers that we would bring in, credentialed speakers. Not to say that Mr. Andrew there is not a credentialed speaker. And we once again want to thank you, Andy, for your patience with us as we overcame the technical difficulties. We had you all set up beautifully until I needed my intro slides,
Uh,
which I hope brought a chuckle or two. And I know that you have to depart soon.
I do.
I believe you have some grandchildren
Yeah,
responsibilities
we've
coming up.
we've we've acquired three grandchildren while their parents had to go out of town, so we're we're kind of loaded tonight.
Well, you're a real trooper and certainly a lifelong amateur astronomer extraordinary. Thank you for your very kind personal remarks, and thank you on behalf of the entire organization. We've been after you to do this now, I think, for a year or two, because you are a true scholar of a very, very significant individual.
Yeah. Thank
And if
you.
you
Thank
sat
you.
on the site of his house, totally unbeknownst to the fact that that's where it was.
Yeah.
But
Yeah.
what actually got you drawn to Heber Curtis in the first place? If I can ask the last question.
It was the experience with Harlow Shapley in '65.
Well, that's right. You mentioned that. Yes.
Yeah.
Yep.
Yeah.
That was a memorable experience, and we actually are trying to retrieve the tape of that. That
Yep.
was an
Um,
incredibly moving experience to
yeah.
be
Oh,
one on one with that famous astronomer.
I'm still looking forward to seeing that.
I've only been promising that for 2 years too.
All right. All right. Well, thank you very much for the opportunity this evening. I'll look forward to maybe doing something again.
Right.
Thank
Thank
you.
you very much.
Thank you.
I still hope to join you under the shadow of the moon sometime other
Oh
than
yeah.
1963. We've
Yeah.
had plans to do it, but maybe in
Well, we got two coming
2020,
up over in Spain. So
2027, maybe.
yeah.
All of you better get that one on your calendars and then start saving.
Yeah. Right. Right. Thank you very much.
Good night, Andrew.